I'm going to explain the production of iron in the blast furnace and answer a question from paper 4 coming in the past paper. The main ore of iron is hematite, Fe2O3. The iron is obtained by reduction with carbonate charcoal in a blast furnace. The furnace is a steel tower about 30-meter high. It is lined with refractory bricks of magnesium oxide, which are cooled by water. The furnace is loaded with charge, which consists of iron ore, the hematite, charcoal, and we're going to know the calcium carbonate, which is the limestone. The first happens that the charcoal here is added as a charge, and also we have here 3 openings in the bottom of the furnace. In the middle we have 2 openings, pumped hot air. Then at the bottom we have an opening, and above there is another opening. When we add the charge, the charcoal and the iron hematite, the first thing happens that the hot air reacts with the charcoal to give carbon dioxide. As the charcoal is carbon mainly, it will react with the oxygen to form carbon dioxide. Actually, the carbon dioxide couldn't react with the iron oxide because it is not a reducing agent. Another reaction happened. The carbon dioxide will react again with the charcoal to give carbon monoxide. Carbon monoxide is a reducing agent. It's a real reducing agent. It can reduce iron 3 oxide and extract the oxygen and leave the iron to fall down at the end or the bottom of the furnace. So we have here the carbon monoxide. After it falls, it will react with the iron oxide hematite to give the iron, and carbon dioxide will comes out from the opening above the furnace as a toxic gases. Now we gain the iron as a molten, but still we have impurities, some impurities with the hematite, which is silicon dioxide, and actually it is an acidic oxide. So in the same charge we add calcium carbonate. It's a limestone. Calcium carbonate, by the heat inside the furnace, it really do a thermal decomposition into calcium oxide plus carbon dioxide. Here the calcium oxide is a basic oxide, easily to react with the silicon dioxide with the hematite, which is acidic oxide, to form a slag, which is a calcium silicate. So here calcium oxide from the decomposition of calcium carbonate will react with the silicon dioxide inside the hematite to give calcium silicate. It's easy. Calcium, we can add here the calcium, and then we add silicon, Si, and O3. So here we have the slag. The molten slag here will be above the iron. It's low density, and it can be taken above the molten iron, which is the bottom. It will be collected at the bottom of the furnace. Now we wrap up what are the reactions in the furnace. First step, the charcoal that we add will react with the oxygen to give carbon dioxide. The carbon dioxide is not a reducing agent. It will react again with the carbon, the charcoal, to give a real reducing agent, which is carbon monoxide, CO. The carbon monoxide will react with the iron oxide, which is the hematite. To give iron, it will extract the oxygen easy, leaving the carbon dioxide to get out as a waste gases. The iron will fall down at the bottom, collected. Still, it contains impurities. So we add another charge, which is calcium carbonate. By thermal decomposition, it will give calcium oxide and carbon dioxide, which will evolve also as the waste gases. The calcium oxide will react with the silicon oxide, which is with the hematite as impurities, to give calcium silicate. Now we get rid from all impurities, and iron, we can use it. The question comes is about iron. Iron is extracted from its main ore in the blast furnace. Name the main ore of iron used in the blast furnace. Of course, the main ore is hematite. The second, name the substance that enters the blast furnace at A. So what comes here at A is the hot air. Actually, it's very important in order to react the charcoal with the oxygen. Name the substance that leaves the blast furnace at B. So what here comes to B? So what comes to B is the slag, calcium silicate. It is low density, so it floats above and it can be extracted. Calcium silicate. Give two reasons for the using coke in the blast furnace. Why we use coke? Coke is a charcoal. So we have a lot of reasons here. We can use it because it releases heat. Actually, it reacts with oxygen, or it acts as a fuel, or increase the temperature, heats the furnace. Mainly, it's a source of energy. Any of them is a question mark scheme answer. Okay, thank you.